In this video we'll cover tidal stream atlases. We'll have just a quick introduction about them and then look at an example. There's a series of 22 of them covering Northwest Europe in the English Channel, and they show the direction and strength of tidal streams at hourly intervals in the form of diagrams. Each diagram is referenced to the time of high water at a specific standard port. So here's a very example of one here, and we've got 2 hours before high water. So that's near the top right hand corner. You'll see this example as I've shown there, but on ours there it's 2 hours before high water. The direction of the arrows clearly indicate the directions in which the tidal streams are setting. So as you can see, the arrows there, that clearly indicates the direction. And the arrows themselves also give an indication of the strengths. So short, thin arrows, weak stream, and longer, thicker arrows, stronger stream. So we've got different sizes of arrows which indicate different values. And of course you can see 02, 04, 07, 13, quite a difference in values there. The figures besides the arrows give the average neap and spring rates in tenths of a knot. So if we have 08 and 15, this means that the neap rate is 0.8 and the spring is 1.5. Here that would be 0.5, 1.3. So that's that information there. Now the tidal diamond information on the charts that you might have seen on your charts, that differs from atlases. That data is numerical, and latitude and longitude is given the position. The diamonds have information relating to hourly rates, 6 hours before and 6 hours after high water, and the data relates directly to a standard port. So let's have a look at an example using the tide tables and one of the tidal atlas. So it's 8th of December at 22:59, and we're off Bishop Rock in the position given. So we've worked out that we're in this position here, and it mentions 07, 15 and the arrow there. So we looked up the position on the chartlet and we've written down neap and spring rates 07, 15, setting 200 degrees. We would now go to the tide tables for the standard port, which is Dover, and we go to the 8th of December and we'd find the two tides either side of 22:59. So we've got 1948 1.4, 0059 6.3. So get those two values, and as I've written them there, 1948 low water 1.4, 0059 high water 6.3 and the 9th. The daily range with the difference between the two, 4.9. Then we want the mean range of Dover, the mean ranges. So if we go to our tidal graph, at the top here it's got our mean ranges 3.3, 5.9. So we can now interpolate to get the 22:59. Note the time given in the question, 22:59, was 2 hours before high water, so that's obviously matched the chartlet we've got here, 2 hours before high water. So we're using the correct chartlet to get the information. So we have 1.5 and 0.7 being the two values there, neaps and springs. For Dover, as we looked on the tidal graph, neaps was 3.3 and springs 5.9. The daily range we got was 4.9, and we're looking for the value on the chartlet. So it's between 3.3 and 5.9, 4.9. So we go 3.3 to 4.9 is 1.6. 3.3 to 5.9 is 2.6. Multiply it by the difference between these two, 0.8. It gives us 0.5. Therefore our mean range is going to be 1.2, setting at 200 degrees. So that's a typical example using the tidal atlas. Pick the values off the chartlet, go into the tide tables and get the times and heights either side of your required time. Write down the ranges of the graph, and then put everything together in a calculation there, and you should be able to get the daily range.